Imagine a night sky where the moon isn't the only dazzling feature. The Earth is crowned with vast shimmering rings stretching across the horizon, sparkling like a miniature version of Saturn's majestic bands. It's astonishing to think about how such a change could ripple through our planet, shifting weather patterns, altering tides, reshaping ecosystems, and even transforming human culture in ways we can barely imagine. The physics of these rings would depend on their size, composition, and stability, but their impact on everything from daily life to global climate could be profound. If Earth had rings like Saturn, we might see new legends born under those celestial halos, while nature itself adapts to this breathtaking new look. So, let's explore what that universe might really be like, what we'd gain, lose, and discover in a world with rings encircling our home. The nature of Saturn's rings. Saturn's rings are among the most striking features in our solar system, composed of countless particles ranging from tiny ice crystals to chunks the size of a house. These particles orbit Saturn in a thin, flat disk that extends thousands of kilometers outward, yet they are remarkably thin, a layer often just a few meters deep in many places. The particles' composition is predominantly water ice, which gives the rings their brilliant, reflective quality, but they also contain dust and trace elements. The structure of these rings is not uniform. Instead, it features a complex pattern of gaps, densities, and divisions caused by gravitational interactions with Saturn's moons. These gravitational resonances create areas of clearing, such as the famous Cassini division, a wide dark gap visible even with small telescopes. The physical behavior of the rings demonstrates fascinating physics. Instead of falling into Saturn due to gravity, many particles maintain stable orbits thanks to a delicate balance between gravitational attraction and the centrifugal force from their orbital motion. Collisions among particles are frequent but gentle. These collisions tend to cause particles to stick or bounce, rather than shatter entirely. Over time, this dynamic results in a continuous, albeit slow, recycling process where material is created, redistributed, and sometimes ejected into space due to micrometeoroid impacts or solar radiation pressure. The rings are not static. They evolve, disperse, and renew slowly over thousands to millions of years. The stability and longevity of Saturn's rings are intriguing, especially since their origin remains a matter of scientific debate. They might have formed from leftover debris after a moon's destruction or from the breakup of a comet or asteroid that wandered too close. If Earth were to acquire a similar ring system, perhaps from disintegrated moons or captured debris, the implications for life and ecosystems could be profound. Imagine a glowing halo arching above cities or casting shifting shades over landscapes. The cultural impact alone would reshape human mythology and artistic expression. Nature itself would adapt, with long-lasting shadows influencing climate cycles and the behavior of nocturnal creatures. The presence of such rings might even alter the Earth's electromagnetic environment, affecting everything from satellite operations to animal navigation. In considering a ring system like Saturn's around Earth, one can't help but marvel at how the physics of particle dynamics and gravitational resonance create such intricate structures. The rings are not just a superficial spectacle. They are a complex assembly of billions of particles held in a delicate balance. If Earth had rings, their interactions with the atmosphere, magnetosphere, and even ocean tides could introduce unpredictable changes. Surpassing mere aesthetics, this leap into planetary cosmology invites reflection on the fragile equilibrium that maintains such features, and whether we might one day see a natural or artificial ring system in our own sky. Historical perspectives on Earth and its atmosphere. Earth's atmosphere and surface have long been subjects of fascination, shaping human understanding of our planet's history and its evolving story. For centuries, scholars have pondered the nature of Earth's protective blanket, how it formed, what variables influenced its composition, and how its layers have shifted over time. Early ideas about Earth's atmosphere centered on volcanic outgassing and the gradual accumulation of gases like nitrogen and oxygen, forming the breathable environment we know today. Yet, before humans could grasp the complexities, the sky was simply an endless expanse, a mysterious canvas whose origins and transformations remained largely speculative. Diverse cultures have historically incorporated celestial phenomena into their mythologies, often interpreting the sky and atmospheric changes as divine or supernatural causes. For instance, in ancient times, widespread volcanic eruptions or unusual planetary alignments were seen as signs from gods, subtly shaping societal narratives about the environment. During the Renaissance, scientific inquiry began to challenge these mythic explanations, with early astronomers and natural philosophers starting to articulate more empirical theories about Earth's atmosphere. Still, the idea of Earth as a dynamic entity, completely intertwined with celestial mechanics, remained a developing concept, setting the stage for later breakthroughs in understanding planetary atmospheres. In terms of Earth's history, the atmosphere has not been static. It experienced significant phases, such as the Great Oxygenation Event, which transformed the planet's environment and biosphere. Scientists now recognize that Earth's atmospheric composition and behavior have been heavily influenced by geologic activity, biological evolution, and external factors like solar radiation. The long-standing understanding that Earth's atmosphere, although delicate, is resilient and vital, roots itself in centuries of accumulating observations, cloud formations, climate fluctuations, and the gradual rise of oxygen, each marking milestones in deciphering Earth's atmospheric history. Reflecting on all this, the thought of Earth's potential development of rings like Saturn adds another layer of curiosity. Historically, such a scenario opens a window into how humans interpret planetary changes and the role of celestial mechanics in shaping life's progress. Just as early thinkers connected the sky's shifting qualities with natural or divine forces, a planet adorned with rings would ripple through our cultural narratives, perhaps sparking new myths, spiritual symbolism, or scientific inquiries. Nature's stories, whether written in atmospheric layers or cosmic rings, continually remind us that our understanding is always unfolding, driven by wonder and discovery. Comparative analysis, Earth versus Saturn. If Earth somehow developed a ring system akin to Saturn's, the visual impact alone would be staggering. Instead of a modest halo visible mainly from space, this hypothetical ring would stretch thousands of kilometers across the sky, shimmering with countless icy and rocky particles. To compare, Saturn's rings are primarily composed of water ice, with particles ranging from tiny dust-sized flecks to chunks several meters across, all orbiting at varying speeds. On Earth, such a structure would require an enormous amount of debris, likely originating from some catastrophic event or a series of planetary collisions, anchoring itself into a stable orbit. The resulting spectacle would transform our skies into a constant, breathtaking display, like a giant celestial jewel glinting overhead. In terms of planetary physics, the presence of rings would drastically alter Earth's gravitational environment on a local scale. The gravitational pull exerted by the rings would create subtle but persistent disturbances on the planet's rotation and orbital dynamics over long periods. Unlike Saturn's rings, which are very thin relative to the planet's size, Earth's rings would need to be extremely stable to have persisted without falling apart or coalescing into moons. This raises fascinating questions about the density and composition of such rings, and whether they could sustain themselves given Earth's stronger gravitational pull and the influence of solar radiation. Tidal forces from the rings could also influence the planet's shape, potentially causing minor but persistent deformation or variations in the equatorial bulge. From a cultural perspective, the impact on human life would be profound. Ancient civilizations might have seen the emergence of rich mythologies centered around this cosmic feature, interpreting it as a divine sign or an ominous omen. Regular sightings of the rings could influence art, literature, and religious practices, elevating them to symbols of eternity and grandeur. The visual spectacle might even impact daily routines. Things like sunsets and sunrises would be dramatically altered, with the rings casting complex shadows across the landscape. Over time, humanity might develop new forms of storytelling and spirituality that revolve around this awe-inspiring feature in the sky. Nature, too, would feel the ripple effects. The rings could modulate the amount of sunlight reaching Earth's surface, sometimes dulling the sun's rays during parts of the year if the rings cast shadows. This would influence climate patterns, possibly leading to cooler temperatures or altered weather systems. Certain animal behaviors could shift in response to the changed light cycles. Migratory patterns might adjust, and plant growth could be affected by subtle shifts in solar radiation. Over long periods, these environmental modifications could even influence evolutionary pathways, favoring species better adapted to a world where the sky is punctuated by a glittering ring, continuously rewiring the natural rhythm of life on Earth. Initial visual impact of Earth's rings. If Earth's rings suddenly materialized in the sky, the first thing that would strike anyone looking upward would be a breathtaking, ever-shifting halo stretching across the horizon. From the ground, they might resemble a colossal, shimmering band encircling the planet, casting intricate shadows and diffusing sunlight differently than we've grown accustomed to. In daylight, the rings would appear as a faint, luminous veil, perhaps tinged with shades of subtle gold, pale blue, or even more exotic hues depending on their composition. The visual drama would depend heavily on the ring's thickness, density, and scattering properties, but would undoubtedly redefine the horizon's silhouette. Their appearance would be startling, especially because Earth currently lacks any such structure. As the rings spun gracefully, sunlight would filter through the particles, creating a dazzling array of shimmering reflections and rainbows that shimmered over landscapes and oceans alike. During daytime, the presence of the rings would partially shade parts of the planet, leading to cooler, dimmer zones beneath their shadows. At night, the rings might cast intricate, moving patterns of light and shadow across the surface, creating an almost surreal double illumination. Bright moon-like segments complemented by streaks of diffused glow. The sky's familiar deep blue would give way to a complex tapestry of glow, possibly with the rings appearing as a vast, faintly glowing band arching overhead. The perception of these rings would be deeply tied to their scale relative to Earth. Given the physics of planetary rings, distributing countless tiny particles orbiting in a stable, flattened disk, they would likely appear much wider and more captivating than man-made satellites or even the thin, faint rings of Mars. If the rings are comparable in size to Saturn's, they would extend thousands of kilometers outward, seeming to hover just above the atmosphere, creating a layered, multidimensional visual phenomenon. The horizon would forever be interrupted by this immense band, making the sky seem more universe-like, more cosmic, than anything most people have ever seen. This planetary adornment would initially evoke awe mixed with disorientation. Images snapped from space would reveal a magnificent, glowing ring system encircling Earth, a stark contrast to the single blue marble humans have known for so long. The rings would generate a new visual language, an aesthetic that would redefine earthly beauty and challenge existing perceptions of our planet's simplicity. Over time, cultural expressions, paintings, literature, photography, would gravitate toward capturing this celestial spectacle, transforming Earth's visual identity forever. The presence of rings might inspire humankind to see Earth less as a fragment of the universe and more as a jewel shining within a cosmic dance, with mankind right at the heart of a broader celestial chorus. Effects on Earth's climate and weather patterns. If Earth were to sport rings similar to Saturn's, the most immediate visual impact would be the shimmering bands stretching across the sky, casting subtle shadows and diffusing sunlight in strange new ways. But beyond aesthetics, these rings could dramatically reshape our climate and weather patterns in unpredictable and profound manners. For starters, the rings would intercept a significant portion of the sunlight reaching Earth's surface. Unlike the moon's gentle glow, these rings would block incoming solar radiation intermittently, causing regular fluctuations in the amount of warmth hitting different regions. This could lead to extended periods of cooler temperatures, especially in equatorial areas, where the ring's shadow would cast a persistent illusion of twilight or dusk. The rings would also act as a filter, scattering sunlight across different wavelengths, changing the spectral composition of the light that reaches Earth. This scattering could influence temperature distributions, potentially cooling some areas while warming others through differential radiation. The unique shape of the rings could induce localized patterns of convection in the atmosphere, potentially affecting jet streams and weather systems. Some regions might experience increased cloud formation as moisture-laden air cools more rapidly in shaded zones, leading to more frequent storms or rain in certain belts. Conversely, areas bathed in direct sunlight might see drier, hotter conditions. The result might be a patchwork quilt of climate zones more volatile than they are today. The rings also have the potential to influence the cycle of seasons. With their orientation slowly changing due to gravitational interactions, the amount of shadow cast and the angle of sunlight could vary over decades, creating irregular seasonal shifts. These shifts might disrupt traditional migration patterns of animals, agricultural calendars, and natural ecosystems entirely designed around present-day seasonal cues. The fauna adapting to a predictable Earth rhythm could face ongoing confusion, and human agriculture might need to redefine crop cycles to cope with unpredictable rainfall and temperature swings caused by the shadowing effects of the rings. On a broader scale, the presence of rings would introduce a new element to Earth's energy balance, potentially stabilizing it during some periods but amplifying climatic extremes during others. The additional reflective surfaces could boost Earth's albedo, reflecting more sunlight back into space and potentially cooling the planet overall. But during certain alignments or ring configurations, the rings might trap heat or redirect radiation inward, creating localized warming pockets. Alien and human cultures might interpret these shifts differently, some seeing it as a celestial blessing, others as a sign of impending change, while nature's delicate balance tries to find equilibrium amidst these new patterns. Influence on ecosystems and biodiversity. The presence of planetary rings might create an otherworldly canopy that echoes the dense forests or expansive coral reefs, but with a twist that reverberates through ecosystems at every level. Shadows cast by the rings could stretch and shift throughout the day, creating a dynamic light environment akin to a constantly moving shade canopy. This fluctuation would influence photosynthesis in plants and algae, possibly favoring species adapted to low light or intermittent sunlight. Some plants might evolve shorter growth cycles or develop specialized chlorophyll pigments to optimize energy capture amid the changing illumination. In aquatic environments, bioluminescent species could become more prominent as they adapt to unpredictable lighting, creating shimmering, luminous patterns that might even serve as signals for communication or mating. On land, the ring's influence on climate and weather patterns could lead to localized microenvironments, further diversifying habitats. For example, areas under the denser parts of the rings might experience less sunlight, cooler temperatures, and higher humidity. Such zones could host unique biodiversity hotspots, with shade-tolerant plants and specialized animal species. Over time, these refuges could become centers of evolution, isolated enough to foster speciation. Conversely, regions bathed in more consistent sunlight might attract different assemblages of species, fueling ecological stratification that is linked directly to the ring's geometry and position. Birds, insects, and other animal life may also evolve behaviors tightly linked to the shifting light and shadow patterns. Birds might time their migrations or foraging to coincide with changing illumination, while insects such as moths and beetles could adapt their navigation systems to the geoclimatic peculiarities created by the rings. Deeply affected by variations in temperature and humidity, certain species could face pressures that lead either to extinction or to remarkable adaptations. These environmental rhythms might even influence predator-prey dynamics, with predators honing their hunting strategies around the predictable shadow movements, and prey species developing protective behaviors or camouflage suited to the changing lightscape. Culturally, the notion of a ringed Earth would shape mythologies, spiritual beliefs, and human perspectives on nature itself. The recurring shadow play might be seen as a mystical sign, inspiring legends about deities, spirits, or cosmic cycles. As societies adapted to these multidimensional rhythms, farming practices, animal domestication, and even architectural choices could be influenced, emphasizing harmony with the shifting environment. Overall, the impact of rings on Earth's ecosystems and biodiversity would be profound, fostering complex adaptations and creating a planet where life continually evolves in response to an extraordinary celestial phenomenon. Impact on human life and culture. If Earth suddenly sported rings like Saturn, the sky would transform into one of the most striking spectacles in the universe. People would wake up to an endless radial pattern stretching across the horizon, their nights glowing softly from reflected sunlight off ring particles. Imagine lying on a hill at twilight and gazing up as shimmering bands encircle the sky, shifting with the seasons and the angle of the sun. This celestial addition would influence not just our visual environment but also the very fabric of daily life, inspiring art, folklore, and worldview shifts. The rings would become an intrinsic element of cultural identity, woven into stories and myths told across generations, symbolizing everything from divine power to cosmic mystery. The presence of rings could also dramatically alter how humans perceive time and space. Historically, celestial bodies like the sun and moon have directed calendars, religious observances, and navigation techniques. Rings surrounding Earth might introduce new patterns of shadow and light, affecting natural phenomena like solar eclipses or the duration of seasons. These subtle changes could compel civilizations to adjust their timekeeping, leading to new myths about the sky or divine entities controlling the rings' movement. More intriguing is the potential psychological impact. Some might find the rings awe-inspiring, fueling spiritual or philosophical debates about humanity's place in the universe, or inspiring new forms of art and storytelling rooted in this altered sky. On a practical level, the rings could influence architecture and city planning. Structures might be designed to align with the rings' patterns or to take advantage of the reflections they cast. During the night, the ambient glow could reduce the need for artificial lighting, potentially altering nightlife and economic activities. Conversely, the rings might pose engineering challenges, such as debris or ring particles falling to Earth, which could threaten satellite operations or even ground-based infrastructure. It's conceivable that space agencies would develop new methods for tracking and mitigating debris from the rings, making space exploration and satellite technology more complex but also opening up novel scientific opportunities. Perhaps most surprisingly, these rings could reshape our cultural landscape in more subtle but profound ways. They could inspire new forms of music, poetry, and visual arts. Think of painters capturing the dance of dust particles, or poets translating the shimmering bands into metaphors for eternity or interconnectedness. Festivals and ceremonies might be created around the ring's appearance, echoing the grandeur of celestial events like eclipses but occurring regularly. On the collective level, the rings might serve as a reminder of the universe's vastness, fostering a sense of unity and curiosity as people look upward, contemplating their place in an ever more awe-inspiring cosmos. Alterations to satellite and space debris orbits. As Earth's hypothetical ring system materializes, the intricate dance of satellites and space debris would face immediate upheaval. Orbits designed with precision around a smooth planetary sphere would become a chaotic ballet, edged with unpredictable gravitational influences from the ring's particles. Satellites circling at altitudes similar to those of the International Space Station or communication satellites, roughly 350 to 500 miles above Earth, could experience subtle but persistent changes in their trajectories. The rings, composed of countless icy and rocky particles ranging from tiny grains to larger chunks, exert gravitational forces that ripple through the surrounding space environment. This means that satellites traveling through or near these regions might find their orbital paths subtly altered, sometimes nudged into slightly different inclinations or eccentricities. The presence of rings might also lead to increased orbital decay or unpredictable re-entries for debris and defunct satellites. The particles in the rings could act like a cosmic sandblaster, gradually increasing atmospheric drag for objects passing through the denser regions. Smaller debris could be diverted into new trajectories that intersect Earth's atmosphere more frequently, raising the risk of uncontrolled burnups or even impacts. Larger pieces of debris could experience gravitational tugs that shift their orbits, potentially causing collision cascades or fragmentations across different layers of the orbital environment. Such dynamics could make tracking space debris extraordinarily challenging, as existing orbital prediction models would need expansion to incorporate the gravitational influences and particle interactions introduced by the rings. Human-made satellites depend heavily on stable, predictable orbits for navigation, communication, weather monitoring, and scientific research. The addition of rings would necessitate continual adjustments, often called station keeping, to counteract the unforeseen gravitational pulls and drift caused by ring particles. Countries and companies operating satellites might need to invest heavily in enhanced propulsion systems or more sophisticated tracking technology to maintain their planned orbits. This increase in orbital maintenance could also escalate costs globally and complicate international efforts to keep space a sustainable environment. Moreover, The potential for increased collision risks would drive a need for more frequent and precise collision avoidance maneuvers, especially in the densely populated low Earth orbit bands. On a more abstract level, the rings could influence the long-term evolution of Earth's orbital environment. As particles shift and interact over years or decades, new patterns of debris distribution might emerge, potentially forming secondary rings or dense zones at certain altitudes. These zones could act like cosmic traffic jams, trapping or diverting sizable chunks of man-made objects, which in turn might create new hazards and complicate efforts at debris mitigation. Ultimately, Earth's space environment would become more complex and less predictable, requiring continuous monitoring and adaptation. All of this highlights how a seemingly breathtaking planetary feature like rings could ripple through the orbital ecosystem, transforming the delicate balance that currently underpins satellite operations and space sustainability. Potential for new navigation and satellite challenges. The presence of intricate rings swirling around Earth would introduce a complex web of challenges for satellite navigation and space-based communication systems. Currently, Earth's satellites orbit at specific altitudes designed to minimize interference, with low Earth orbit, geostationary, and medium Earth orbit paths carefully planned to avoid collision and signal disruption. But introduce rings, composed of countless particles ranging from tiny dust to larger debris, and everything shifts. The rings could create dense, unpredictable zones of debris, significantly increasing the risk of collision for satellites passing through or near these areas. Navigating through this particulate obstacle course would demand more sophisticated collision avoidance algorithms and real-time monitoring of ring particles, complicating satellite trajectory planning. Satellites operating at or near the plane of Earth's equator, the typical orbit for geostationary satellites, might find themselves repeatedly skimming the edges of these rings. That would necessitate frequent course corrections, increasing fuel consumption and ultimately shortening satellite lifespans. The rings could also cause signal scattering or distortion, especially for radio waves passing through the denser regions. This could lead to degraded communication quality, delays, or even temporary blackouts in coverage for global positioning systems, broadcasting, or data relay services. Furthermore, the rings could interfere with the precise timing signals crucial for navigation, potentially making GPS systems temporarily unreliable or requiring significant recalibration. Space agencies and private satellite operators would face additional hurdles when calibrating or deploying new satellites. Launch trajectories designed with a clear understanding of current orbital zones would need adjustments to avoid potential ring debris or particle clusters. Satellites might need to adopt alternative orbits or increase shielding, which would raise costs and technical complexity. Launching through Earth's ring system might also dictate new, carefully mapped corridors to minimize collision risks, akin to air traffic control but on a cosmic scale. In the long run, this could lead to a proliferation of more advanced, autonomous spacecraft capable of real-time hazard detection and avoidance, fundamentally changing the template of satellite deployment and space traffic management. On a broader level, the presence of rings would ripple into cultural and technological realms. Public awareness of Earth's altered appearance and the ongoing risks to space infrastructure could shape attitudes towards space exploration and satellite monitoring. The need for constant vigilance would stimulate advancements in debris tracking technology and international cooperation, transforming it into an ongoing, collective effort. In essence, Earth's rings would turn space into a more contested, dynamic environment, one where navigation and satellite operations would need a new level of sophistication, resilience, and adaptability, echoing the tumultuous beauty of planetary rings themselves. Energy and light reflection by the rings. When considering the hypothetical scenario of Earth adorned with rings similar to Saturn's, the way sunlight interacts with those massive, icy, and rocky bands becomes a captivating point of focus. Unlike Saturn's rings, which are composed mainly of ice particles, Earth's rings would likely vary in composition, size, and density, directly influencing how they reflect, absorb, or transmit light. During the day, sunlight would strike the rings at various angles depending on Earth's position relative to the sun, casting intricate patterns of reflected light onto the surface and atmosphere. The rings would act as an enormous, shimmering reflector, diffusing sunlight across a wide area and potentially creating a permanent glow in the sky, especially during dawn and dusk. These rings would serve as giant mirrors, bouncing and scattering solar radiation in complex ways. Because the particles are tiny, ranging from micrometers to meters, they tend to scatter light broadly, a phenomenon called scattering, which also explains why clouds and the sky appear blue. In the case of Earth's rings, a similar scattering effect would create a luminous halo around the planet, reducing the intensity of sunlight reaching the surface during certain times of the day. This even distribution of light could lead to a softer, more pervasive glow that diminishes sharp shadows and alters the natural rhythm of day and night. Depending on the thickness and the density of the rings, the planet's overall brightness in the sky might be significantly heightened during specific periods. Another effect stems from the rings' reflective properties influencing local climate conditions. These structures could reflect a portion of the incoming solar energy back into space, acting somewhat like a planetary albedo booster, or conversely, trap certain wavelengths depending on their material composition. For example, icy particles reflect visible light efficiently but absorb more infrared radiation, affecting thermal balances. This duality creates nuanced feedback loops where the rings could both cool and warm Earth at different times or locations, subtly shifting climatic patterns over millennia. The combined effect might be a more stable yet subtly altered radiation intake, influencing everything from weather systems to plant growth cycles. Culturally and artistically, rings would transform human perception of the sky, elevating it from a simple celestial backdrop to a dynamic, living spectacle. The shimmering bands would become a defining feature of the planet's visual identity, inspiring myths, artistic expressions, and spiritual symbolism. In terms of environmental impact, the rings could influence animal behavior. Some nocturnal creatures might adapt to the reduced darkness during certain times, while others may become confused by the constant reflections and shifting glows. Overall, the energy and light reflection dynamics introduced by Earth's hypothetical rings would deepen the planet's complexity, weaving a shimmering, luminous net across the sky that would emphasize yet subtly alter the delicate balance of energy reaching our world. Influence on night skies and astronomy. If Earth suddenly had rings reminiscent of Saturn's shimmering bands, the night sky would transform dramatically, turning into one of the most breathtaking and scientifically intriguing visions possible. The first thing everyone would notice is a sprawling, luminous circle arching across the heavens, casting intricate shadows and diffusing starlight in new, complex ways. Unlike Saturn's rings, which are composed mainly of ice particles that reflect sunlight with a dazzling clarity, Earth's hypothetical rings would likely contain a mixture of ice, dust, and perhaps even larger chunks of debris. This composition would influence how they are illuminated. During the day, sunlight filtering through or around the rings could create subtle, shimmering glows and a soft, diffused light pattern that might even affect the local climate slightly by blocking some of the sun's direct rays. From an astronomical perspective, these rings would serve as a natural, ongoing spectacle that might inspire new ways to observe celestial objects. The proximity and size of Earth's rings could give astronomers a dramatically different field of view, potentially spoiling parts of the sky for observational astronomy but also offering new opportunities. For instance, eclipses could become more complex. When the moon passes in front of the sun, the rings might cast additional shadows and produce unusual solar eclipse phenomena. Think of a layered, shimmering shadow pattern that shifts as the rings move and Earth's position changes. The visibility of distant stars and galaxies could fluctuate depending on the ring's orientation, occasionally obscuring parts of the sky with a broad, semi-transparent barrier of particles. Looking through telescopes, astronomers might find that the rings add an extra layer of complexity to their observations. The particles in Earth's rings could scatter and reflect light from distant stars and galaxies, creating a faint halo or glow around bright objects, which might complicate precise measurements of celestial bodies. Conversely, the rings might serve as natural filters or diffraction screens, offering unique ways to study light dispersion on a planetary scale. For amateurs and skywatchers, the presence of rings would turn simple stargazing into a dynamic, constantly changing dance of shadows and light patterns. Every twilight and dawn would be infused with a surreal quality, as the ring's orientation relative to Earth shifts with the seasons, producing breathtaking vistas of shimmering bands against the backdrop of dusky twilight. Culturally and historically, These rings would reshape humanity's relationship with the night sky, turning it into a permanent monument of cosmic artistry. Such a spectacle might inspire centuries of art, poetry, and mythology centered around this celestial adornment. It could also influence the way we navigate and measure time, with the shifting appearance of the rings acting as a celestial clock or calendar. Scientific communities would likely devote enormous effort to understanding the rings' composition and origins, making them a central focus for ongoing research. Ultimately, Earth's rings would transform the experience of night, both visually and scientifically, casting a new light on our place in the universe and deepening our connection to the cosmos. Long-term geological and geophysical changes. If Earth suddenly donned rings like Saturn's, the planet's internal dynamics would face a series of profound alterations over geological timescales. The presence of such a vast, suspended disk, even if composed of dust, rock, or ice, would influence tectonic activity in subtle yet persistent ways. The gravitational pull exerted by the rings could generate additional stresses along fault lines, both at the crust-mantle boundary and internally within tectonic plates. Over millions of years, these stresses might lead to a shift in the frequency and intensity of earthquakes or volcanic activity, especially in regions directly beneath the ring's shadow or gravitational influence. The subtle inflation or compression caused by ring gravitational pull might also induce localized heating, altering magma movement and contributing to new magma chamber formations or shifts in existing ones. Beyond tectonics, the rings would impact Earth's geophysical evolution through their effect on the planet's magnetic field. Earth's geomagnetic field is generated by the dynamo action of its liquid outer core. The gravitational tug from the rings, though slight compared to the Earth's mass, could introduce minute variations in the Earth's rotational inertia, thereby influencing the dynamo process over vast timescales. Such variations might cause subtle fluctuations in magnetic poles or even alter magnetic field strength. Over geological epochs, these shifts could modify the shielding effect Earth's magnetic field provides against solar and cosmic radiation, indirectly influencing atmospheric composition and the stability of layers like the ionosphere. In time, the distribution of mass within and around Earth would slowly but surely evolve, with the rings acting as a constant but gentle source of external torque. This transfer of angular momentum could lead to long-term changes in Earth's rotation rate, gradually altering the length of days. Such shifts might seem negligible in the immediate future, but, over thousands or millions of years, would produce measurable differences in solar day length, climate cycles, and the pattern of ocean currents. The persistent gravitational interaction might also cause the Earth's axial tilt to fluctuate, creating long-term cycles of climate change that could reshape ecosystems and geological features alike. Over eons, these combined shifts could craft a planetary narrative fundamentally different from what we see today, one where geophysical processes are continually influenced by the majestic, encircling rings. Philosophical and cultural implications. If Earth ever bore rings like Saturn's, humanity's perception of the sky would shift dramatically, reshaping our philosophical outlook in profound ways. The night sky would become a constantly changing tapestry, a symbol of celestial artistry, but also of cosmic grandeur beyond immediate human comprehension. Such rings could prompt deeper questions about our place in the universe. Are we merely occupants of a planetary system that can be adorned with majestic, ring-like structures? The idea of Earth sported with rings might suggest that worlds are not static, that they can be modified, beautified, or even endowed with symbols of cosmic significance. This could lead to a renewed sense of wonder, or perhaps a philosophical awakening, regarding the interconnectedness of natural laws and human influence on our environment. On a cultural level, the rings would likely influence mythology, art, and symbolism. Ancient civilizations interpreted celestial bodies as deities, signs, or omens. Rings would elevate this symbolism into an entirely new realm. They could become a universal motif of eternity, cycles, or divine intervention, inspiring stories that blend science and spirituality. For some societies, the rings might evoke themes of protection or of a cosmic boundary, encouraging new mythologies that intertwine their existence with these cosmic adornments. In art and architecture, perhaps we'd see references to concentric circles echoing the rings, a visual reminder of our planet's altered appearance. The rings might influence cultural rituals, celebrations, or even political symbolism, just as certain symbols like the Star of David or Celtic knots carry layered meanings. Earth's rings could become symbols of unity or a shared cosmic heritage. However, the existence of earthly rings could also provoke existential reflection. Would our current philosophies surrounding nature and progress be challenged by a planet that now appears visibly different? Many might see the rings as a reminder of human ingenuity or conversely, as a symbol of ecological disruption. If, for example, the rings resulted from pollution or artificiality, they could carry an ambivalent meaning, blurring lines between natural beauty and technological hubris. In philosophical circles, debates could open about what it means to live on a planet that we've decorated, and whether that signifies mastery over nature or a dangerous hubris. The rings could inspire questions about sustainability, aesthetics, and the ethics of planetary modification, prompting society to reevaluate its relationship with Earth in ways both nostalgic and futuristic. Ultimately, the transformation of our planet into a cosmic spectacle would ripple through culture, spirituality, and philosophical thought, blending the tangible with the metaphysical. There's an inherent beauty in contemplating a world where Earth's rings serve as both a literal adornment and a symbol of human curiosity, an eternal reminder that perception deeply shapes understanding. The rings might serve as a mirror that reflects our longing for connection with the cosmos, provoking us to rethink what it means to be inhabitants of a living, spinning orb. Would we see ourselves as guardians of a jewel in the universe, or as mere spectators in an endless cosmic dance? These are questions that our very culture and worldview would grapple with long after the rings had become part of Earth's celestial signature. Possible effects on Earth's rotation and orbit. If Earth suddenly sported rings akin to Saturn's, the gravitational dance governing our planet's rotation would likely shift in subtle but profound ways. The rings, composed of countless particles ranging from tiny dust grains to larger chunks of ice and rock, would exert gravitational pulls on our planet. While the total mass of Saturn's rings is estimates far less than Earth's, even a comparatively thin ring system could create a gravitational tug that slightly alters Earth's angular momentum over time. This could lead to minute changes in the length of our days, potentially making Earth's rotation either slow down or speed up depending on the alignment and distribution of the ring particles relative to our planet's axis. The Earth's orbit around the Sun could also experience marginal modifications. As the rings orbit along with Earth, their gravity would introduce additional gravitational forces, creating a tug-and-pull effect. Over thousands or millions of years, these forces might cause minor but cumulative shifts in Earth's orbital parameters. The most noticeable change might be a slight increase in orbital eccentricity or a shift in the planet's axial tilt, which could have cascading effects on climate and seasonal cycles. The gravitational interactions might also produce small orbital resonances, leading to oscillations that influence Earth's interaction with other celestial bodies, including the Moon. Culturally and ecologically, the presence of rings would transform how humans view the planet. The sky would be dotted with shimmering bands, possibly visible even during the day, a constant reminder of a celestial adornment, much like the rings of Saturn but on a larger, earthly scale. This could influence artistic expression, religious symbolism, and even our sense of planetary identity. From an ecological perspective, if the rings disturbed Earth's rotation or orbit enough to affect the length of days and seasons, it could lead to dramatic shifts in climate zones and ecosystems. Migratory patterns, plant flowering times, and animal behaviors might all adapt to the new rhythm set by altered orbital and rotational dynamics. In essence, Earth's hypothetical rings would be a delicate gravitational addition that, over time, might subtly reshape our planet's day-to-day motions and big-picture orbital characteristics. The interplay between celestial mechanics and natural cycles would likely be a slow evolution, but its imprint on everything from ocean tides to climate patterns would be undeniable. Such a scenario sparks curiosity about the intricate balance that keeps Earth stable, how even small increases in mass distribution around it could ripple through the fabric of planetary physics. If Earth suddenly sported rings similar to Saturn's, the implications would ripple across both the natural environment and human culture in complex, unpredictable ways. From a scientific standpoint, Earth's rings would likely consist of countless particles, ice, rock, dust, spanning a vast orbital zone that encircles the planet. Their presence would alter the way sunlight interacts with Earth's atmosphere, perhaps causing shimmering glints of reflected light and creating striking visual phenomena akin to auroras but on a grander scale. The rings' composition and density would determine whether they cast subtle shadows over the surface or produce more dramatic, dance-like patterns across the globe. One interesting aspect involves gravity and orbital mechanics. Earth's existing gravitational field would have to accommodate these new rings, which would settle into a stable orbit if the particle sizes and velocities were just right. The rings' existence could influence tides subtly, especially if larger chunks of debris drifted closer or collided. Over time, collisions within the rings might generate new dust and particles, making the system more dynamic than Saturn's, which has a relatively stable ring structure. However, unlike Saturn, where the rings are thin and bright, Earth's rings would likely be less orderly and may even break apart or accumulate in certain zones depending on the planet's gravitational perturbations and moon interactions. Culturally and psychologically, Earth's rings would be an unsettling yet mesmerizing sight, forever altering human perceptions of the sky. Cities and landscapes would offer views of shimmering bands arching across the atmosphere, inspiring awe, reverence, or even fear. Artistic expression would adapt. Imagine paintings, films, and poetry celebrating the celestial spectacle, while some mythologies might recenter around the rings as divine or ominous symbols. The rings could impact our sense of time and space, fostering new calendars based on their appearance or phases. Additionally, if the rings were thick or bright enough, they might impact weather patterns by influencing global heat distribution, perhaps cooling parts of the planet or creating localized microclimates. The environmental effects could be profound. Increased asteroid or meteoroid impacts would be a real concern if debris within the rings occasionally spiraled inward, creating a risk of bombardment. Conversely, the rings could serve as a kind of natural shield, intercepting space debris before it reaches Earth's surface. Over generations, people might develop new technologies to navigate or even harvest materials from the rings, turning them into resources for space industry. Such a colossal modification to Earth's appearance and orbit would challenge everything we understand about planetary stability and life, whispering of a future where our home planet becomes a much more visually spectacular, but also more complex world to inhabit. Imagine gazing up into the sky and seeing those shimmering rings arching over your city, transforming the familiar night into a celestial spectacle. If Earth had rings like Saturn, our day-to-day life would shift in fascinating ways, altering how sunlight filters through the atmosphere, creating stunning, ever-changing shadows, and perhaps even influencing weather patterns over time. These rings would not only redefine Earth's visual landscape but could also inspire new cultural expressions, from art to mythology, as humanity adapts to a world where the sky's canvas is forever expanded. From a scientific perspective, adding rings would challenge our understanding of orbital dynamics and planetary physics, inviting us to ponder how such structures would form and persist amidst Earth's gravity. Would they be stable, or would they constantly evolve, breaking apart and reforming? It's a tantalizing what if that sparks curiosity about both the universe's nature and our place within it. So, what do you think? How would life's rhythm change with Earth adorned like Saturn? Share your thoughts, and if you're intrigued by these cosmic possibilities, stay tuned. There's so much more to explore. Future videos will dive deeper into the mysteries of our planet and the universe, uncovering extraordinary ideas worth dreaming about. Keep gazing upwards and curious. Who knows what wonders our universe still has in store?